Hello, everyone. We are Senior Design Team at IntelliBus. We're made up of members Noah Chong, Shadman Ahmed, Thomas Talbot, and Yue David Pan. Our team was advised by Dr. Vijay Matasetti. So what's the problem? COVID-19 has shown so many inefficiencies with our public transportation system. Human congestion in public areas and transportation leads to higher costs and higher rates of virus transmission and exposure. People are looking for ways to more efficiently utilize public transit. That's where IntelliBus comes in. We provide real-time passenger data capture and analytics. We can accurately tell you how many people got on a bus, at what time, at what stop, and give you a history of passenger traffic. IntelliBus can provide transportation authorities a better way to utilize resources and provide better services to their customers. There are two main components in IntelliBus: the IoT embedded devices and the web application. The IoT device consists of a microcontroller, tracking sensors, and an LTE-M module. A web application is responsible for providing a real-time dashboard of bus locations, passenger counts, and viewing pertinent graphical statistics and analytics. On the bus, for our hardware, we have two VL53L0X LiDAR sensors that can accurately measure the distance of an object within 30 to 1000 millimeters. An Arduino Nano reads those LiDAR sensors via an I2C interface. If the distance returned by a sensor is less than a set threshold, then a digital output pin is set. Finally, a Nordic semiconductor NRF9160 transmits those passenger counts and other data over an LTE-M network. It calculates passenger count by the order of rising edges from those nanos' digital outputs. Here's our passenger counting mechanism. Two sensors will face the path of a passenger's entry and exit. When a passenger moves in and out of a bus, the two sensors triggers at different times. We've considered these edge cases: capturing invalid data while the bus is moving, a person standing in front of the sensors. We also look for preventing double counts, and we also tested the reliability and the timeliness of those sensors. Our APC hardware uses MQTT to publish data to our IoT Cloud Hub, where it's processed by an MQTT broker. This raw data is then stored in AWS S3. The data then gets prepared by AWS Kinesis and Lambda and exposed through an API using AWS API Gateway, which our web server fetches and displays to our end users. Here's an example of what that map display looks like. As you can see right here, we see a catalog of all the bus stops, and also a heads-up display of the bus and route information, which tells us the location of the bus, the total passengers, the total capacity, and the current bus status. And finally, here's the analytics dashboard, where people can view the buses deployed, the live total passenger count, as well as all the historical data captured by our system over time. All right, let's go ahead and take some time to look at a live demo. Inside of the shoebox is our device, and right on the top left corner, we have a video of our heads-up display. And as you can see right now, we have the total passengers increment as soon as the people enter from the quote-unquote entrance side of our live demo. And as soon as they exit off the bus, our device goes ahead and calculates those people coming in and out of the bus and decrements to appropriate values. Finally, let's look at this test in an actual bus at Georgia Tech.
Stop. Our current passenger count is 3, now it's 2. Another person got off. Now the count is 1. And another person's getting on the bus.
Hello.
And 3 people got on the bus, and it successfully counted all 3 of those people. So the count went from 1, 2, 3, and then 4. Connected. And our passenger count is now 4 as we counted. Okay, we're already at another stop, so we have 1 person getting off. And we have 1 person entering the bus. So our passenger count
It's still
should
4.
still be 4, and it is. And the current Passenger count is still 4. Alright, we're pulling out a stop, but I'm not sure if anybody's going to get off at this one. So somebody is getting off at this stop. And the passenger count decremented to 3 is correct. And somebody might be getting on. And somebody is entering the bus. And the passenger count incremented to 4 correctly. And should be sending a packet over the network soon. Okay. And the latest passenger count is 4, which is correct.